Okay, now we're going to talk about one-side limits. So notice a one-side limit, you'll know that whatever value x is headed towards, it's either you're looking from the right side, the positive side of the x value, or you're looking from the negative side, the left side. Okay, that's what a one-side limit is. And it's asking from this side right here, where is the height? Or if it's a plus sign, it's still asking from only that side, what is the height? Okay, so knowing that, let me just erase what I just drew so that's not all. And then when you have piecewise, notice this says x is greater than or x is greater than and equal. All the values get bigger on the right side of C. This is the bigger side. So this is these symbols. This is the lower or the smaller values. So this is the left side of C. So notice what this says. The limit as x approaches 3 from the right side f of x. So which one of those, this is what you do. You just look at the inequality sign. Which inequality sign says that x is bigger? The one that looks like that, that's the right side. So then this is all you have to do. You rewrite the limit as x approaches 3 from the right. You take this part of the function, this piece, because that's the right-sided, that's the positive-sided function, and then you substitute 3 in for x. 3 plus 1 is 4. All right, so let me move this out of the way. So now look at what we have. We have 2 from the left side. Well, what did we say a few seconds ago? The left side is where things get smaller, so the inequality sign looks like this. So the limit as x approaches 2 from the left side is just going to be at the height of 2. Well, the height of 2 is just 2. Okay, now we're going to do one-sided absolute value. So the first thing you're going to do when you notice the numerator doesn't match the denominator or vice versa, factor out whichever one needs to be factored. So in this case, 5x subtract 5 both have a 5 in common. And now you have the heights, because that's an invisible 1 down here. You have the height of where the hollow dots will be. And whatever is the opposite inside in the denominator absolute value or parentheses, that is where the graph has been shifted to. So the opposite of negative 1 is 1. We're at a height of 5. So from 1 on the x-axis, you go up 5 and you go down to negative 5. And because this is positive, you go to the right. So because this is a positive graph where the above the x-axis, the graph goes in the positive direction, and below the x-axis, it goes in the negative direction. And because this is one-sided, though, we look from the left side. So here's the left side, here's the right side. Well, on the left side of 5, we are down there at negative 5. So that's how you do those. All right, I'm going to cover this up. So now what we have is, okay, so I explained something poorly the other day because I tend to reverse things. So I'm going to clear it up here. When there's a negative sign in both the numerator and the denominator, you actually don't want to factor out the negative sign in the absolute value. You do not want to do it. You want to leave it there. And you want the numerator and the denominator to match. So instead of factoring out a negative 4, we're just going to factor out a 4. And now the parentheses and the absolute value match. And this is why that is important. So a positive 3, that would be negative 3. So a positive 3 is what zeroes out the absolute value. So we know on the x-axis where the graph shifts to, and then that's a slope of 4 over 1, so 4, not a slope, but the height. So that's where you put the dots. And then this is going to be a negative graph, although last week I said, well, negative divide by negative, but we can't think about it that way. That's why you have to leave the negative sign on the inside. So here is a good way, a good strategy. You only need to check two numbers. Since we know 3 is the center and that's going to be undefined at 3, just pick 4 and pick 2. So I'm going to plug in 2. 2 is to the left of 3 and 4 is to the right of 3. So this is the plus side, this is the minus side. So when I plug 2 in here, the opposite of 2, negative 2 plus 3 is 1. 1 times 4 is 4, so that's a positive number. That's the fraction bar. So when I put 2 in there, the opposite of 2 is negative 2. Negative 2 plus 3 is 1. 1 times 1 is 1. So this is a positive sign and this is a positive sign. So we know this will be above the x-axis. Now we're going to plug in 4. Well, the opposite of 4 is negative 4. Negative 4 plus 3 is negative 1. We'll do the same thing down here, but the absolute value of negative 1 is positive 1. So positive 1 times 1. So then you have a negative sign above a positive sign, which is negative. So this tells you if the sign ends up being negative, we know that graph will be below the x-axis and this positive will be above. And then we just have to look as we're approaching 3 from the left side. So the left side is the 2 value. We're up here at a height of 4. So remember, on these absolute value where there's a negative attached to an x, do not factor them out. Only in this case factor out the 4, and then you have to plug the values in. But remember, when it looks like this, the graph will be going in the negative direction. Negative, normally this would be up here, so this got reflected, and this got reflected. Okay, now we're going to do the piecewise ones again. It's the same thing. Notice this is negative 1 from the plus side, right? So if negative 1, here's the positive side. Well, those are the sides where the values get bigger. From the left side, smaller. So we look right here, and then you just write the limit as x approaches negative 1 from the right side, and the piece of the f of x is the 2x subtract 2, and then you plug negative 1 into here. 2 times negative 1 is negative 2. Negative 2 subtract 2 is negative 4. And then this one right here. Oh, these are both on the right side. So here we go. This one's on the right side again. But then you rewrite the limit as x approaches 0 from the right. You pick the right-sided limit, 2x subtract 2. When you plug 0 in there, you get a height of negative 2. Okay, now we have these rational functions that are one-sided. Notice this says the limit as x approaches 3, positive 3 from the left side, from the negative side. But what do you notice right away, or should notice? Nothing cancels. So these are the ones that we talked about. When nothing cancels, that means it's headed towards an asymptote. But what we want to know is, what is the behavior doing on the left or right? And on this case, it's the left. So what is the behavior doing on this left side? And if you're not great at graphing, this is what we're going to do. We're going to pick a number really, really close to 3 from the left side. So 2.99, I'm going to go out 4 decimal places. Well, 3 times 2.999, that's really close to 9. And then x subtract 3, 2.9999 subtract 3 is negative 0.0001. And when you divide that, you get a really large negative number, which means that graph is headed towards negative infinity. And that is the work that you would show me, just like that. Okay, we're going to come over here. Now, these are the type that you think, well, that's one-sided and it's rational. It should be positive or negative infinity. But this is what is called a distractor. They mess with the brain. These are when limits actually exist. So this is what I mean. Notice that x plus 3 in the numerator. Well, in the denominator, that function down there is going to will factor to x plus 3, x plus 2. So that's going to cancel, leaving a 1. And then we rewrite the limit as x approaches negative 3 from the right, which means 3.001. The numbers get bigger, right? From the right side, I'm sorry, negative 2 point, from the right side. If this is negative 3, from the right side, that would be negative 2.999, whatever. But watch, you don't even have to really worry about that too much, because look it, when we plug in, well, yeah, actually I do want you to still do that. Negative 3 from the right would be negative 2.9999 plus 2 leaves you negative 0.9999. Well, when you do 1 divide that, you are really, really close to a height of negative 1. Just like if you plugged in negative 3 to the left side, if you typed in negative 3.0001 plus 2, you still end up with this number. This is called a distractor because this is one of those graphs that might actually look something like this. Or right down there, both sides are headed to a height of negative 1. So again, on these one-sided limits that are rational, and I'm just going to kind of rewrite things, you're going to have to be really, really careful, because sometimes one-sided limits, even though they're rational, there will actually be a height. And we just factored the denominator. Those canceled, leaving x plus 2. And then I chose a number, so looking at negative 3. From the right side is negative 2.9999. From the left side is negative 3.0001. But all we cared about is from the right side. So right there, I did 1 over negative 2.9999 plus 2. And that became 1 divide negative 0.00, let's see, 9999. And then when you can rewrite this, the limit as x approaches negative 3 from the right, and we ended up with 1 over x plus 2. And then that's going to approximate negative 1. Or you don't even need to approximate. That's where we're headed. From the left or from the right side, we're headed towards negative 1. All right, that's it for this one.